Hello everyone, I am Somireddy Ujjwala from RJKT Basar and I am here to present my internship project washing machine simulation using PIC16F877A microcontroller. This project was a part of my embedded systems internship conducted by Emertxe Information Technologies. Through this presentation, I'll take you through what I did, how it works, what I learned, and why it was such a valuable experience. Let me start by explaining a little about washing machines. A washing machine is something we all use to clean clothes. It takes care of washing, rinsing, and spinning all by itself, which saves us time and effort. Modern washing machines use sensors and microcontrollers to control all the functions. They are smart enough to choose the right amount of water, set the timer, and even adjust to different cloth types. For example, soft clothes need a gentle wash, while dirty jeans need a strong wash. So we can say that a washing machine is a great example of an embedded system, and that's what I tried to build and simulate in my project, a simplified version using microcontroller. During my internship, I got to learn many interesting things. Here is a summary of the major topics. Firstly, C programming and how it works in embedded systems. Embedded C, which is used for programming hardware. The PIC16F877A microcontroller, which was the core of my project. And I also learned about microprocessor. I learned how to use tools like MPLab XID, XC8 compiler, and PICSimLab. I worked with LED indicators, a digital keypad, and a CLCD display. Each of these topics helped me understand how a software and hardware work together. Let's look deeper into the C programming part. I started with the basics like data types, which is integers, characters, and floats. And I learned how to use operators like bitwise operators, arithmetic operators, ternary operators, etc. Then I studied about control structures like if else, switch case, and I used loops like for, while, do, while to repeat the actions. And I also learned about the strings. I also understood how a C program flows, starting from the main function and going through different parts. Functions and modular programming. I learned about functions which help us break the program into small parts. Instead of writing everything in a one big file, we can divide it into smaller ones. For example, the main code goes in main.c and the code goes in digital keypad.c and so on. This is called modular programming and it makes the code easier to understand and manage. I also used .h header files to define things like constants and function declarations. Let's move on to the next slide. This slide shows some advanced topics that were very useful. I worked with arrays to store data like keypad values, pointers which helped me to pass data between functions efficiently, and macros. Macros are like shortcuts to make code more readable. And I also learned about bitwise operations like checking specific bits in a port using a port B and 0x3e or 3f. And I also learned about delays and time functions. Delay ms function and delay us functions are built-in functions from .xc.h header file, which were very useful for creating time gaps between operations. Now, what exactly is an embedded system? It's a small computer to design to do one job like controlling a washing machine or microwave. It has limited hardware but is programmed to work perfectly for a specific task. I also learn about memory types. Here, ROM like EPROM or double EPROM for storing programs permanently, and RAM for temporary data. Some devices also uses hybrid memory like OTP, which is used in toys and appliances. This part helped me understand how a system stores and handles the data. Here comes the main part, a microcontroller. A microcontroller is like a mini computer on a chip. It has everything in it like CPU, RAM, ROM, timer, and input output pins. We used the PIC16F877A microcontroller in this project. And another important thing I learned was electrical basics like a VCC equals to 5 volts, ground equals to 0 volts, and how we use pins to turn things on or off. I also learned about microprocessor. A microprocessor is a central unit that processes data and instructions in a computer system. Unlike microcontrollers, it needs external memory and input to functions. And I also learned the difference between a microcontroller and a microprocessor. Microcontrollers are used for specific tasks, while microprocessors are for general use, like in computers. In the project, I used a 4x4 digital keypad. It was connected to port B and each key was detected using logic and masking. There are two modes. First one is level mode and the second one is state mode. Level mode is to detect if a key is currently being pressed. State mode is to detect a new key press only once. For LEDs, I used them to show different stages of the wash cycle. I turned them on and off using simple logic and software delays. CLCD interfacing. CLCD stands for character LCD and I used a 16x4 display. It shows 4 lines of 16 characters. The data lines D0 to D7 were connected to port D and control pins like RS and E were connected to port E. This display was very useful to show the welcome messages, washing modes, water levels, wash programs, and final status like program completed. It made the project user friendly and easy to understand to the user. Let's move on to the next slide. Project objective. Now let's talk about what my project was supposed to do. I wanted to build a washing machine using the microcontroller PIC16F877A. It should take user input through the digital keypad, perform wash, rinse and spin stages using embedded logic, and everything will be shown on CLCD display. And finally, it should be tested and simulated using MPLAB XIDE and PICSimlab. These were my main goals and I was able to achieve them step by step. To complete this project, I used the following 3 tools: MPLAB XIDE, XE8 compiler, PICSimlab. MPLAB XIDE. This is where I wrote my code, built the project and debugged it. And XE8 compiler. It converted the C code into machine language so that the microcontroller can understand it. and simulate. So, the PIC lab. Finally, this simulation tool where I tested everything virtually without physical hardware. These three tools made development smooth and gave me hands-on practice like real embedded system. I used several hardware components which were also called peripherals in this project. Let me explain you everything. First one is CLCD. We used 16 by 4 CLCD to display everything. And this CLCD display shows all the important information to the user. And digital keypad. This digital keypad allows user input for selecting wash programs and water levels and starting or stopping the machines. And the third one is LED indicators. It represents the different washing stages like water fill, wash, rinse and spin. It was connected to port B pins and toggled based on washing cycle stages. And the fourth one is buzzer. Buzzer alerts the user at the end of each stage. And fifth one is fan. It simulates the spinning motor during the spin cycle. And the sixth one is water level sensor. It simulates detection of water fill level, whether it was low or medium or high, etc. Timer module, used to create delays and time the operations. And also it is very used for timing buzzer sounds and blinking the LEDs. And the last one is EEPROM. It stores last used program or user preferences. It is optional. These peripherals helped me and make the simulation more realistic and interactive. Let me now walk you through how the system actually works. First, I press switch 5 to power on. Then the CLCD shows a welcome message. Then I use switch 4 to scroll through different washing programs like daily, heavy, quick wash, etc. And a long press on switch 4 selects the program. Next, to select the water level from auto, low, medium, high, max, etc., we use switch 4. Similarly, how we selected washing program, we need to select the water level by long pressing the switch 4. After everything is set, pressing switch 5 starts the washing operation. During the wash, rinse and spin stages, the CLCD updates the message on the CLCD and the corresponding LED turns on. Finally, a buzzer sound alerts the user when a stage completes. After spinning is done, the display shows program completed, remove clothes on the CLCD. This is how the whole simulation behaves, just like a real washing machine. I also created a demo where I ran the full project using PIC16F877A. You can see how each part responds: the CLCD, keypad, LEDs, buzzer and fan. Before watching the demo, let me show you how I have written the code in MPLAB. These are the header files required for the project and these are the source files required for the project. After writing the code, we need to build it. So build is successful. Now I'll show you how it works in PIC16F877A. This is the PIC16 lab. We need to select the file. We need to select .hex file. And we need to select the PIC Genius board and PIC16F877A microcontroller. So, to power on the washing machine, we need to press key 5. So, the washing machine is powering on. To scroll down the programs, we need to press switch 4. Yes. To select the washing program, we need to long press the switch 4. Heavy is selected. Similarly, we need to select the water level by long pressing the switch 4. To start the washing machine, we need to press switch 5. So it takes 50 seconds. The CLCD display shows wash cycle and remaining time. If we want to pause the washing machine, we can press key 6. So the washing machine is paused. To resume it, we can press switch 5. So the washing machine is running. After completion of this, the buzzer will alarm. So CLCD is displaying rinse cycle. After completion of this, we will see how much time does it takes to complete this function. Now spin cycle. Yes, program completed. Remove clothes. For washing program heavy and water level low, it takes 50 seconds to complete, as we have already seen. In the demo, we clearly saw that how the system initialized and displayed a welcome message on the CLCD, and also how I selected a washing mode using the keypad, and then CLCD displays wash cycle, rinse cycle, spin cycle. After the completion of these 3 cycles, the buzzer sounds and the CLCD display showed the final message program completed and remove clothes. During the project development, I incurred several errors and bugs. I found errors like buzzer not turning on, bouncing effect on keypad, and LEDs not indicating correct stage, which I corrected through code modifications and wiring fixes. In conclusion, this internship was a great learning experience for me. I got hands-on practice with real-time embedded systems. I learned how to design, code, and debug a complete system using embedded C. I explored tools like MPLab, XIDE, XC8 compiler, and PIC16Lab. Most importantly, I gained confidence to build microcontroller based projects independently. This project has given me a deeper understanding of embedded systems, and I am excited to apply this knowledge in future projects. The skills I gained will be valuable in my future, and I am grateful for the opportunity to work on this project. Thank you so much for listening to my presentation. I am really grateful to Emertxe Information Technologies for providing me with this internship opportunity and guiding me throughout the project. The knowledge and experience I gained will be valuable in my future endeavors. I am also thankful to my mentors at Emertxe for their support and feedback, which helped me improve my project and presentation skills. Thank you again for your attention, and I hope this presentation has given you a good understanding of my project washing machine simulation using PIC16F877A.